Okay, so this is my Ansys project. Unfortunately, it reset, so this time it will actually be going through doing it. I've already done geometry, as you can see in the mesh. We've got this. It is 10 millimeters by 500 millimeters, so a pretty long toner. We have the surface already set up as a surface, but deleted my mesh, it seems like. So I'm going to need to create a new mesh. Mesh is normally right here. So I actually don't know what they normally do with mesh. Surface body. Generate. Where's my mesh? Generate. Nope. Okay, I actually don't really know how to get the mesh from here. It's the design model there, right? Oh, okay. And this is a mesh model. Okay, edit mesh model. So the design modeler, you just made the shape. L2 is 10, L1 is 500 millimeters, and then you made it a surface based off the sketch. And so we get this body. Now, mesh would open up. Yes, meshing. Okay, meshing. Ooh, yes, it did not reset it. Okay, that's very nice. I was scared to reset it last time. Okay, you can see the mesh is very, very detailed. Thankfully, I've got a good computer, so it didn't take too long to do anything. But I did it by first doing these two sides with 100 divisions on each. I made a kind of messy mesh in the middle, so then I did 500 divisions along the whole thing. Then it was only messy at the start and end, and then we did a full face meshing to clean it all up. That's how we got this very nice, pretty thick mesh. Um, didn't end up doing any like better detail closer to the sides like the last time because it wasn't really a reason to. We have plates on both sides. Inlet, outlet, top wall, and bottom wall. Yep, that should be everything in here. Moving on to setup. Edit? I don't know. Should already have a file. But okay. This is where I think it didn't save. I think there was something messed up with where you save the stuff to. Key behavioral changes, yes, I understand. Cho. Okay, let's see. What is missing? Unless nothing is missing. Let's see. Wouldn't be in plots. Graphics. Yeah, don't see reference values. Are these right? Nope, they're not. That has 10 meters per second, which is not right. Anyway, fluid, air. Hello. Okay, this is right. Density 1, viscosity 0.001. Um, Next thing down from there is boundary conditions. Inlet is a velocity inlet now. We did pressure inlet for a second, but we switched it back to velocity inlet so that we could get the 5 meters per second in. Outlet is pressure. Let me see. Is this where I change the velocity? Yes. 5 meters per second. Bam. Let me check with the assignment. Oh, no, I'm messing. Well, give me a moment. Did this all last night. And then it was too noisy, so I was just going to do it in the morning for the recording. Okay, here we go. Yep, plus top is plus 3, bottom is minus 2. Okay, close. Awesome. You should be 5 now. Biscuit. Okay. Inlet, outlet, internal, and the 2 walls. Now we make these moving walls. Don't change the name of them, no. Moving wall, this is the bottom wall, so it should be -2 meter per second, as they say. Then the top wall will be +3. Bam. Okay. This sheet's really going everywhere. Bam. Bam. Okay. Let's make sure I didn't forget anything for this section. Reference values, blah 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 blah. Blah blah blah. That sounds right. Initialize it. Last time I didn't initialize it, but probably should. Bam. And run calculation. Hopefully I didn't forget anything. Run calculation. 500 iterations, yep. And hit it. A whole lot of scale residuals. Scale residuals, scale residuals. Okay. And now, to see any of that, I will do it through a plot. I think. Could probably just skip over to the next step, but graphic contour. Actually, I think don't you want a velocity contours? Velocity contour. Obviously, I've already taken all the photos, everything, but no. Tier surface of body. Sounds right. Yes. Bonita. Look at that beauty. Look at that beauty. As you can see, this plate is going backwards, but there's a lot more flow in this direction. So, the stagnation point, I believe, that's what this is. I guess that'd be for pressure. Anyway, you can see all the arrows are going in that direction. But even though this plate is going in the same direction as the normal flow, the boundary layer makes it actually still slower, even though you'd think logically that it'd be faster. Well, I guess it's also moving slower than the 5 meters per second, so it kind of makes sense anyway. Yeah, okay, so it's because this is 3 meters per second, and this is 5 meters per second. So no matter what, this is going to slow it down, but not as much as if it was going 0 meters per second. So, make your pipes move, I don't know. Okay, that should be everything for this. Time to head over to solution, I think? Maybe result. Let's find out. We were about to find out. We were about to find out. Look at these beautiful graph. Obviously over here it's a little bit more weird. Goofy. Like my 3-dimensional arrows. So 3 and D. Like these nuts. Oh god. It's a lot of arrows right there. Okay. Is it? Is it even loaded? Doesn't look like this. Edit. Hello? Is solution what I'm in right now? No, I'm not in solution. No. I don't know. Maybe I am. Okay, results. Because it doesn't look like it's opening anything. It's not. Edit the results. Yeah, see, now it's actually opening something. There we go. Okay, I don't. Because that's mesh. Setup and solution. Is this the same thing? I don't remember. Anyway, okay, but this is the right place. Okay. Oh, it looks. Oh, I've got a lot of my stuff here. Okay, nice. Don't have to go over as much. Let's see. Obviously, all of these surfaces are still here. Symmetry 1. I don't exactly understand what symmetry 1 is, but it is the body. So, pretty sure symmetry 1 is just the surface that is named like a normal thing back here. Like it's named the interior surface here. For some reason, it's named the symmetry in here. I don't know why. Anyway, added a few lines here. I don't know if you can see them, but inlet is over here. Midpoint I put in the middle. Oh, now you can see it. I don't know what I did. Anyway, you can see them. We got an inlet one over here. These are for, this is what I'm going to be exporting. So the inlet, the midpoint, slightly after the midpoint, and close to the end, but not too close. And these are what they're going to be using to, my partner is going to be using to calculate the theory. I'm not sure if he needs every single one of these, but I decided to give him, the in and the out, and then a small variation, with like a given distance. I need to make sure I send him all the densities and everything. Anyway, so there's a pressure contour, as you can see, pascals, numbers. Let me whip out the velocity with the vectors. Skier, as you can see, there's a bunch of little arrows in here. Oh, that's not what I need to do. There's a bunch of little arrows in there. You see the nice gradient that we have here. What I actually do to do this, create some full contours. That's kind of it's kind of given, and then I made the vector one, put it on top, put these. Okay, now using these to get the data, go over to chart viewer. Table chart viewer. And now, yes, pressure chart. Yeah. Okay. First velocity chart. As you can see, the midpoint and endpoint. I believe that's what was asked, right? Middle and end of the pipe on the same graph. Bam! Right here, and then you can export right here. And yeah, I did along the the midpoint and the endpoint. Then my post midpoint and my other thing, my inlet. What the frick was I doing? Oh yeah, pressure chart. Pressure chart. So that is actually the endpoint, because obviously it's the lowest pressure. So it goes from this side to that side. So just flip it around. Inlet. Bam! You can see the gradient here that we saw. That we see right here. We know this is obviously velocity. Oh, that's weird. You can see how it kind of pushes out in a circle. Ish. Then obviously settles into like a what's called a uniform flow, something like that. Uniform something. It's like it has one shape for the velocity usually, but in this case it's just pressure. So the pressure become uniform in a line. There's a midpoint, right after the midpoint it's slightly less, and then by the time you get to the end point it's significantly less. And then I just export it from here, pushing export, because I put my pressure and my velocity, and I just send those over to my friend over Discord so that he can make it. Now let me see if I forgot anything. Okay, velocity contours with vectors. Oh, let me zoom in on the boundary. I'll do it on this one instead of going back to the other one. Bam, bam. Zoom in on the boundary. I think I already did zoom in on the boundary. Yeah, I did. Don't know why. Don't think I did. Yes, like I saw show you before, these arrows are going back and these arrows are going forward. Because here, this is going to be the most velocity backwards. Because this is going to be the closest, like infinitely close to that would be the most. The closest to the backwards moving, and she is not slipping, it's staying there. And then as you go towards this center line right here, you can kind of see how that's a very small arrow this way. It's a very small arrow that way. Around here, there is a point where there is no velocity. And then you go up, arrows get bigger until the max of exactly, I'm assuming it should be exactly 5 meters per second is the maximum here. Because I don't think this adds to it. It just takes away as you get closer to it. If this was like 8 meters per second up here, then this might be slightly bigger. And it'd actually go from 8 through like 6, and then like 3, and then down to 0. But yeah, nice big arrows. I like this design. It looks good. It's just such a thin mother chucking pipe that it looks terrible from out here. It just looks like a weird color band. And you can see, the stuff going on back there. Pressure contour, show velocity, determine maximum velocity. Okay, well these last two ones he's going to do, because using fluent results, so I sent him the fluent results. And and if he needs anything else, I shall send it to him as well. But as of now, I have not sent him whatever other things he might need. But he'll get back to me in a day or two. And I hope this thing doesn't lose any progress again. Oh, was it? Was this one that lost progress? I don't know why. Anyway, that should be everything. Let's go play him.